for this. Okay. Okay, let me make this a little bit bigger. Yeah, I think this should be enough. Okay, that's okay. So today I'm going through this document, basically give you some information, not just review, but give you some information about what kind of question, or maybe in what way I'm going to ask what kind of question in this document. And so I'm going to tell you something. If you have any questions specific, please just raise your hand in the middle. So the first point is that, okay, in this document, I kind of separate the topic from homework 1 to homework 6, and with fictional homework 7 as well. But in general, the knowledge about makefile, as well as some of the options that you need to use for G++, those are basically, that piece of knowledge might show up in any of the question, because it's actually for any homework, you actually will encounter those things, okay? And the second thing is that in the final exam, as now at least, almost every single question, I shouldn't say almost, I said every single question, that they will come with a code segment that's actually related or maybe extended from the homework assignment, okay? And therefore, I'm basically ask a question as I show you what kind of question I'm going to ask, and then that usually will, together with a code segment or makefile segment, things like that, or maybe sometime I will give you a command line, say G++ minus CC1, and then minus STD, C++14, and then minus F, dump record, and blah, blah, blah. And then things like that. And then ask you some explanation, or basically you tell me whether this will work or not. Okay, so just let you know that it will come with that. So just let you know that those are the style of the question that I will be asking. All right, so now let's actually take a look at homework 1. So what homework 1 really asks you to do is ask you to work with files. So we're looking at my heel and my break, and some of the video, for example. Let me see where there must be some video. Actually, I talk about the source code, kind of go over the source code of my heel and my break regarding how you can manage the file. So over here, there's question I'm going to ask. For example, well, how do you actually verify that the output you're actually getting from my heel is correct? So the thing is that, well, how do you, many of you actually, not a few of you, many of you ask me, oh, can you give me a file that's actually supposed to be the output so we can actually see if your program is doing correct or not? I want to tell you that not just homework number 1, but many of the homework, the importance of homework assignment is actually want you to learn how to actually decide whether your program is behaved correctly or not. And the thing is that sometimes you use test cases, but testing is a really, really sophisticated software engineering task. By the way, the testing, there are so many issues you need to worry about, but a lot of this case, you need to use tool. For example, homework assignment number 1, the tool that you should be using is called diff. The diff is actually going to help you to decide. So the thing is that, well, when you work on this homework, an important goal for you to know when you do the homework or after you've done the homework is that, well, how do you actually, in general, what kind of tool you need to be using, or what kind of paradigms you need to follow in order to know whether your code is doing what it's supposed to do. It's not as simple as say this output must follow this character. That is going to be really narrow if you actually do that. But the important thing is that you actually have to know why you're doing this, so then you can develop a paradigm to deal with that. Okay, in homework 1 is diff, but in homework 2, homework 3 is a little bit different. Okay, so one of the things that's really interesting, I want to actually tell you that the second things I try to emphasize in this course is that in a lot of things, once you learn how to use a language construct or a tool, you should be able to have the capability as a intermediate programming class like ecs36b. You should have the capability to build the tool yourself. For example, diff. Think about what is diff. Diff is looking at two files and compare bits by bit or byte by byte to see if there's any difference between these two files. If you think about what we're doing in homework assignment number 1, is you have a my break and my heal. And what my break and my heal, you are actually going through one of the files, look at byte by byte, and output to the other file. So if you follow the same paradigm, but instead of output, you actually try to read two files simultaneously, and then try to do a comparison. If any byte or any bits, they're different, then the diff is going to return, say, hey, they're different. If you think about what we have done in homework assignment number 1, the hidden agenda is that you already have everything to build your own version of diff. All right, so that's something which so homework 1, let me, to be honest with you, the current version of the program is that I'm actually going to provide a segment of code which is similar to the program you have seen or you work on for homework assignment number 1. But the way I modify, I'm actually asking you whether this is the correct way to do diff, if we're going to do that. Okay, so that's kind of the question about homework assignment number 1. Any question about this part? Yes. Yeah.
About how long will this take?
Some of them is actually very short. Some of them very short because I only want, for example, homework 1 is going to be short. It's probably 15 to 20 lines of code. But some of the program could be really long. For example, I want you to search for all the template being used in this, all the template, the STL, the standard template that you're going to, just like one of the homework assignment I gave to everybody, is that you're looking for the word std : and then looking at the name, looking at the template introducer, which is a smaller and greater than. And so in that case, I'm going to give you maybe a few pages of code for you to just search what are the template being used in that page of code. Okay, so the thing is that if you need to read very carefully, understand the logic about the program I gave you, it must be short. But if I want you to, there is a heuristics for you to easily find out what you're looking for, then that could be a little bit longer. Okay, does that answer your question? Any other question? Yes, please.
But you're providing code, we're not writing. Or is there
I will, nothing will be, I'm not going to give you any pseudocode, and you don't need to write any pseudocode as well. Okay, you don't need to write any pseudocode. I might actually ask you to write, for example, one line of code or one line of command about what you can do in this kind of situation. Just one line of code. But whenever you write a line of code, my grading policy is that if I can see you actually know what you're doing, even you make a syntax error, like a missing a misspelling, that's okay. However, there's a very important, because one of the question I forgot, homework 3 or homework 4, there's a difference between reference and object. So what's the difference between a object and the object reference? There's a declaration after the class name, you need to put an and sign. So that is one single character that's really critical. So if you miss that one, then that's going to hurt you. Okay. Yes.
Final on paper.
On paper, yes. So everything is going to be on paper. Yeah. Okay. So yeah, just keep asking questions as I move along. Okay. So let's actually look at homework 2. So homework 2 is essentially try to help you to learn how to manipulate string. Because we're actually looking at 5-letter words. And for example, one of the part which I talk about in this particular video is actually interpret how do you actually build a program to actually figure out impossibility. So it means that those are the letters that's actually going to be impossible to have. For you to solve a word, though, you can actually eliminate all the string from the input. So that is the logic. Is essentially homework 2 is actually dealing with string. How do you actually be able to handle string, even though you don't know STD string, but the thing is that the C string and STD string, they're basically doing the same thing. Okay. So the thing is that, well, how do you actually be able to, we already told you how to do impossible, but in this routine, we might twist a little bit. For example, you're not eliminating the string from an array in the memory, but instead, I'm actually want you to, how do you actually remove the string from a file? You can see that homework 1, homework 2, and a lot of this homework is actually dealing with files. So what's the difference between, say, something in the memory and something in the files? And I think as a programmer, you need to actually know the difference. What do you mean by having a lot of information I store in the memory and to the file? What's the difference? And also, what is the programming trick I need to do in order to handle this two kind of situation differently? That's essentially what we have been asked you to do between homework 1 and homework 2. So the other issue, which is in the homework 2, in fact, in this video, I actually see that in the screen, there is a function called string dupe. I also include, I forgot which lecture, after this, there is a function called string dupe. And this is a function I might ask you about its implementation. What is a string dupe? String dupe, let me just tell you, it's essentially, string dupe essentially is equal to string copy and the malloc of something and to the source, something like that. Well, if you do a Google, by the way, if you do a Google string dupe implementation, string dupe implementation. Okay, no, this is string dupe implementation is too much. I don't like this. It should be a simple implementation, just one line. This is I feel that they're too much. Oh, this one looks almost one line. You see that? This one, string dupe, is return string copy and malloc. Okay, in fact, string dupe is just like this one line code. String copy malloc of the source of the string. And the thing is, I like to ask you about string dupe is that always remember to +1. You remember, anybody can tell me why when I want to create a memory space, I actually have to do string length SRC, which is the source +1. Yeah. The character at the end, right? And the other thing, just to let you know, is that the memory you actually get it back from malloc is always power 2. I don't know if you know that. When you ask for 13 bytes, you're going to get 16 bytes or 32 bytes. because the way malloc memory is they always arrange memory in chunks of power 2. So +1 might not be necessary for some situation. If my string is 13 character, I just allocate 13 character, it will give me enough. So the bug is actually, how do I say that? It's not consistent. You forget +1, sometimes it works, sometimes it doesn't work, depending on if your string is exactly 16, then you better allocate to 17. Okay, so I forgot to mention is that there's a lot of, as a C++ programmer, Java programmer or Python programmer, you never need to worry about this. But C programmer, you always have to remember the +1 is so important because this actually costs a lot of trouble if you forgot to do that. It's hard to debug, by the way, because it's not happen all the time because the malloc always give the power 2, whatever the chunk memory that you have. Okay. All right, so that is a string dupe. Remember, I should say string length of source +1. Okay, this is essentially the implementation. I will send this up as well. Okay, that is essentially using string copy malloc string length, and then that's the string dupe. Okay, and remember, you always remember to free this after using this. Okay, that's homework 2. So homework 3 is the first real assignment that we actually ask you to design and implement C++ classes. Over here, there was a few important concepts. The first, you try to do what's operator overloading, especially that you can actually go to the directory. I mean, for example, let me ask you this question. For operator overloading, for std : OPS means that there are 6 different operators that we can overload. What are those 6 operators? Can actually someone tell me? Yeah. Less than, greater than, and then what? Greater than, equal, and smaller than, equal, and then not equal, right? This is 6 operator, right? You can overload. This is std OPS. That's actually defined under utility. Okay, include utility. If you do include utility, it should have that. And then on each of the computer, you can look for the utility file. You don't really have to look into that. I will not ask you that much. But may I ask, if you want to do 6, which 2 you need to define? Yes.
Equals and then less than.
Equal and then less than, right? Only 2 of them you need to include. If you don't know why, go back to check the video when we cover that topic. Okay. So you need to only define 2 and then you get 6. All right. Is that right? Anyway, okay. Another few topic I mentioned here is the difference between an object and an object reference. I mean, that is important. It's not just about syntactically what is adding an and, but also semantically, what does that mean? When you define this is an object versus this is a object reference. Object reference is almost like a pointer in C, but they use the notation differently. So which means that you're actually passing the address of a memory location for the object instead of make a copy. Okay, so if you actually use object, essentially this is a copy of value. But if you actually use a reference to an object, then essentially you do not make a copy, but you actually pass in the value. And that's actually going to see the result will be different. If you actually do it as a reference, when you make the multiplication inside a function that's called by reference, by the way, hopefully you still remember this concept called the difference between call by value, which is the default C function, and call by reference. And there's another things called call by name, which I'm not going to ask you. If you're interested, you can Google it. There's basically in programming language, making function call, there are three. Call by reference, call by value, and call by name. Okay, three different things. But the difference between object and the reference is really the difference between call by value and call by reference. Any question? And also, okay, yeah, please.
The object reference as an argument.
Right, right. It could be an argument, or it could be a member attribute that I actually define as a reference, meaning that that particular reference is going to be passed. So, okay, let me actually tell you this. This is confusing for every single C++ programmer, especially you learn C first, is that whenever you see an M, that is really, really a pointer in C, but they actually represent differently. It's really a pointer means that pointer, the address has to be set in the way when you do assignment. Okay, so every time you see an M, it's really a pointer, but syntactically, you have to use the syntax of the original object. Okay. All right. Any other question? All right, so that's the other function is the design implementation of dump to JSON. I'll probably ask something related to recursion that I really want to show you as this is example about dump to JSON is the example about how you can define a facility to the classes or objects such that you have this standard function or standard member function almost with every single class. And such that when you travel through the complex object is basically just recursively call the same function. And that is actually a very interesting paradigm. The textbook didn't talk about it, but in reality, in real world, we want to build something more complicated as an object that this capability is almost like a design pattern for you to learn. It doesn't have to be dump to JSON. It might be something else. That's you actually see that how do you actually place a function every class, and then you can actually just calling each other recursively and accomplish a really interesting goal. Okay, so then we actually talk about homework assignment number 4. So homework assignment number 4 is about JSON to object. So the purpose of homework assignment number 4 is trying to bridge the gap between two different object-oriented representation. One is actually more of a compiler time. One is more of a runtime. So, so this is another emphasis. You probably hear me a lot saying that whether this is done in compiler time or whether this is done in the runtime. So homework 4, homework 5, they're both actually try to emphasize the difference and how a C++ programmer need to know the difference. So homework 4, the difference is that because JSON is a runtime representation, meaning that the compiler does not really actually check before you run the code. The compiler doesn't have a way to check whether this particular JSON is actually syntactically correct, whether this JSON has the important element that's needed for your operation. Everything has to be determined at runtime. That's essentially what's happening in JSON, or a language like a Python is also essentially everything is done at the runtime. But C++, on the other hand, is a compiler time language, most of this, with the exception of homework 5. And what do we do in homework 5? Do you still remember? What did you do? Some of you just turned it in. What's homework 5? I forgot.
The record layout. With
The record layout. Jonah, right? Yeah, okay. I remember his name as well. I asked him too many questions. So record layout is also what? Record layout for what? Inheritance. Inheritance is what? Virtual inheritance. And virtual inheritance always have something called vtable. Vtable pointer, and vtable pointer has to be determined at runtime. So that's why because you introduce, by the way, if you don't have the word virtual, if you remove the word virtual, then C++ is a completely compiler type language. But because they introduced the concept called virtual, then now we cannot determine a compiler type. We'll go over that when I actually review homework 5. But homework 4 is different. Homework 4 is saying that I have a C++ object. How do I actually convert it to JSON? How do I actually convert it back? By the way, that conversion partially, that's useful. Of course, it's always useful to convert from one representation to the other, because in this world, we just have so many different type of information, different format. When I want to integrate all this information together, I need to have the really, really rich capability for me to do this kind of conversion one way or the other. When I can do this, I can accomplish something called interoperability about different information sources. And then I can actually do the best I can with the data. So homework 4 is essentially look at the different capability with homework 3. Then we look at the JSON to object, and then I basically give like a 2-piece of source code, which is go over what kind of engineering issue or implementation issue that you need to worry about. And I also want you to read one code. I never ask you to modify but you need to look at this code more seriously, because there are some segment of code will be from ecs36b JSON.cpp, which is basically talk about how some of the utility function is being done. Okay, it's not that long. Okay, by the way, that source code. If you have any question about that code, yeah, please ask me before the final exam. Okay. All right. Another thing which I want to tell you is that how do you represent the concept of persistent object or mobility object? What do I mean by persistent object? Persistent object means that when you type Control-C, you kill your program, your object is gone. If you run the program only in C++, and then whenever your program exits, your object, whatever you create, a thing, a person, a GPS location, or JV time, they're gone. They basically got eliminated from the history. And the thing is, persistent object means that that object still exists somewhere. And next time when I run the same program or different program, I can bring this object back in life, in my memory. That's called persistent object. Mobile object means that I'm actually creating object on my device. I actually get to move that object from my device to your device or to the other server, and that's called mobility, object mobility. So those kind of concept is actually, you can actually do that with that capability with whatever facility you develop, homework 3 and homework 4. Okay. Now I want to actually go over the homework 5. Homework 5, I consider is probably the hardest homework this quarter. Okay, usually the hardest homework is about doing a lot of this kind of distributed processing. This quarter, I actually kind of de-emphasized the JSON RPC side. So it's about web programming. You can actually learn when you really doing this on your job to do web programming. But this homework is difficult because it really go deep into what is exactly on your memory when you actually try to create some object as a C++ programmer. It's complicated. It's just the difference between multiple inheritance and virtual inheritance, and how do you actually put the layout. So the way the program segment I'm going to give to you is going to be showing the contrast about, I give you some piece of code about classes design, and watch out whether I have the keyword virtual, I have the keyword virtual, I have a virtual function there or not, or I have a virtual inheritance. I will give you those kind of code, and then I actually give you a memory layout. And then I want you to actually tell me whether you think that that memory layout is a reasonable representation about the code I show you. Okay, I hope you can answer this question without actually typing the code into the computer. Of course, that's the way, that can be the way to do it. Just run the program and generate. But the thing is that it should be, the way I'm going to ask you should be straightforward enough that you can actually immediately tell what is the issue. I mean, for example, I gave you a piece of code with virtual, with a few virtual keywords, but the memory layout doesn't even have one single entry of the table. And you don't have to run the code. Immediately follow the principle. You say, hey, this piece of code, this piece of memory layout cannot generate from that piece of code because it doesn't have a vtable pointer. It needs to have whenever you have a keyword virtual. Okay, so that's some of the question you want to. And in this homework 5, I also want to tell you that at least you need to know that there is a tool called CLAM with what option to generate that layout, and some of the compiler flag like a -D, -I, -L. Those are try to controlling the if-def processor that you actually have. The preprocessor like pound, if-def, pound, and if. I want to actually give you some segment possible. Not sure. Okay. All right. Homework 6. I actually haven't finished the program with the question with homework 6. But homework 6, the source code will be from the exception directory about how to generate the exception, the syntax about whether the question I plan to ask you is that if I actually write the code this way, do you think there's any uncaught exception? So with exception, the most important mistake that people tend to make such kind of trouble is that they actually designing a program, they actually throw an exception, but it didn't get caught. And the thing is that if that happened, your program will crash and show you some kind of embarrassing message. So those are the exception. Homework 7, the source code will be this 2 directory. The main directory will be the second one. The first one, the only thing I will ask you is about that OpenAI.http. That's the source code that's actually provided by OpenAI community. And look at the code and look at, for example, try to find out what is the STD library. But then this part, the last link was the lecture I gave Monday, that there is a lot of interesting usage about STL standard template library on map and the pair, map and pair. So the STL related question I'm going to ask you are related to the 3 template. I'm only going to ask the 3 template is map, pair, and vector. Okay, I'm only going to ask question related to the 3 template about their usage, and probably I'm going to show you a piece of code and basically ask you, and the iterator, by the way, this is important. Iterator, how do you actually do an iterator in that case? Okay, that's pretty much all the things I'm going to ask. I'm going to provide this. Let me actually try to upload this because I make some edit, and then you can provide all you can ask me all the questions you want at this point. Hold on 1 second. Yes, it's over here. I'm going to add the file, upload the file.
Where do we find the OpenAI.hp file?
Go to repository. Okay, a long answer, Jonah, just go back to the YouTube, watch every single video, eventually we'll see. The short answer is, sorry about that. With love and respect, this is the directory, sfelix to OpenAI _ JSON CPP. And under here, you actually will see the program ecs36b OpenAI.hpp. That's the code which I actually modified. By the way, this is different from the original OpenAI.hpp because I actually make a lot of, not a lot, make the change of this if-def because I actually modify so it will support the JSON CPP library instead of the other JSON library they're using. Okay, and one of the important thing I do want to mention is that looking at this code, you can see that the last lecture, why I'm talking about map and pairs, because with map and pair and with operator overloading, any of you still remember which operator we overload on Monday? There's only one thing we did, the operator overloading. The bracket, right? The bracket. See, if you do operator overloading on the bracket and you know map, you know pair, you can implement your own JSON library. It shouldn't be too hard. If I feel most of you, you've probably never done this before, but this is really shape yourself into a good programmer. Is every time you encounter this, you use whatever you have, you see other people doing, you should be able to recreate. Develop your own. In that process, you will become a really good programmer. Okay, and that's the yeah. Okay, the auto is a way that let the compiler figure out that what should be the data type. Let me actually give you an example. Okay, so if I write a piece of code, I can say class, person, star, pp is equal to a function called xyz something, right? I can write a piece of code like this. So this code essentially imply this function xyz is what? The function prototype of the xyz is actually person star. Person star xyz void. This is called function prototype of this function xyz. Okay, I'm not doing inheritance. I'm just basically assuming that is the type. I mean, of course, this could be another case, could be SP person, but class SP person is public person. Okay, if there is an inheritance relationship over here. Okay, so then of course, this could be the function prototype could be this. So one way to write this piece of code is that, okay, I actually do auto pp is equal to xyz. What does this auto means is that compiler will figure out from the rest part of the code, especially this code, and try to derive what should be the return type of xyz. And then based on that information, I will change the the auto into whatever type it is. Yeah.
In this case, what data type would it be?
What?
In this case, what data type would it be?
In this case, it will be, depending on what's the function prototype. So if the function prototype is the first case, then the data type of PP is going to be person star. If the function prototype SP person star, it will be SP person. So that's why auto. That's why it might have problem with inheritance. So when you write this code, you thought it is person star, but it's actually not.
SP person. Would it be a type? Would PP be a type of SP person or person?
SP person. It will try to match the exact type. That's what auto is trying to do. Yeah. If there is a two identical function with a different return type, the auto will generate we can try that. It will either generate a syntax error because there is ambiguity, or it will actually just pick the first one and then give you a warning saying that we actually have a two, but we can write a program to try it out. Okay, yeah. So it basically assume that there is no ambiguity in that case. So in some sense, I feel, do you really think that auto is necessary? Auto is kind of nice, right? For me to write it out, but the code becomes, number one, become unreadable. Because when you say auto, I have to actually look into that. The second thing is that it might have ambiguity I need to worry about. So that's why I typically, I don't use auto. I just, if I know what it is, I would just write it out. Yes.
Do you plan on curving or?
No, I'm not curving. Did I say the first class? I never curved in my career. I never curved in my career. Okay. I mean, just for some reason, it's my belief that curving is provide disincentive for the student to collaborate on discussing.
So the panel's open laptop?
Open laptop, open internet, everything. You can bring anything you want, except you can use ChatGPT, but just don't chat with another person. Okay. Other than that, it's fine. Okay. All right. Good luck. And
Luckily, like,